In a remote region of Siberia, a frozen lake became the focus of scientific attention after a series of unusual measurements were recorded beneath its surface. The lake itself is unremarkable. It has no permanent settlements nearby. It has no documented industrial activity. For decades, it attracted little interest. That changed when seismic monitoring stations began detecting repeated signals originating from beneath the lakebed. The signals were not strong enough to be classified as earthquakes. They did not resemble volcanic or tectonic activity, and they were confined to a very specific location. This video examines what has been recorded beneath this lake, what explanations have been proposed, and why none of them fully account for the data. Location and background. The lake is located in a region of continuous permafrost, where the ground remains frozen year-round, sometimes to depths exceeding several hundred meters. Permafrost in this area has been stable for thousands of years. Temperature fluctuations are minimal. Large-scale geological changes are rare. Historically, the lake has shown no unusual behavior. Satellite imagery from the early 2000s shows consistent freeze and thaw cycles, typical for this latitude. There are no known fault lines directly beneath the lake. There are no recorded volcanic systems nearby. There is no evidence of human excavation or underground construction. For this reason, early anomalies detected in the area were initially dismissed as sensor error. However, the readings persisted. Seismic data. Beginning in late 2024, seismic stations monitoring the region began registering low-frequency vibrations beneath the lake. These signals shared several unusual characteristics. They were repetitive. They originated from a fixed point. They occurred regardless of surface weather conditions. Typical seismic activity produces irregular waveforms. These signals did not. Instead, the data showed repeating patterns over extended periods of time. Geophysicists compared the waveforms to known sources, including ice cracking, underground gas movement, permafrost collapse, distant tectonic activity. None of these matched the observed data. Gas-related seismic signals usually appear in bursts. Ice cracking produces sharp, irregular spikes. Tectonic activity spreads outward across fault systems. The signals beneath the lake remain localized and consistent. According to internal notes from researchers reviewing the data, the term most frequently used to describe the signals was structured. This does not imply intention, but it does imply organization. Surface anomalies. Around the same time seismic anomalies were recorded, changes on the surface of the lake became visible.